Absolute value inequalities are similar to compound inequalities. So there are two possibilities. You have and you have the or case. So when we do absolute value equations, we found two solutions. So that's what that first example here is trying to show us. For x equals 1, it breaks off and you have x equals positive 1 and x equals negative 1. So it's not a set of solutions. It's just simply, let me put them on the number line here. Two solutions. We have a solution at negative 1 and a solution at positive 1. We don't shade because it's not a set or multiple solutions. So for inequalities, when we're doing this, if we have x is greater than 1, the absolute value of x is greater than 1, we would break that into 2, and we have x is greater than 1, but we also, with absolute value, just like for equations we have a negative, the same thing applies for inequalities. We are going to have that negative 1, but just like when you guys divide or multiply by a negative, when you set your solution to a negative, you need to flip that sign. So we also have x is less than negative 1. So on your number line, it's not or equal to, it's just less than or greater than. So we have an open dot at 1 and negative 1. So if it's greater than 1, that's going to go to the right, but less than negative 1. So when it's greater, so if you guys are trying to pay attention or find any hints here to help you, when it's greater than or equal to, you're always going to shade out because that's going to be an or. So greater or greater than or equal to. If it's an or, absolute value inequality, you guys are always going to shade out. So if we look at the second one, or the third one, I'm sorry, still two inequalities. We have x is less than 1. X is, flip the sign, greater than negative 1. So we would still have our open dots. At 1 and negative 1, except this time it's less than 1 but greater than negative 1. So when we have less than or equal to, that's going to be our and we will always shade in. So less than and inequality, and is in. Greater or greater than or equal to is your or, and they're going to shade out. So that's just sort of a quick way to check yourselves once you guys solve them and graph them. So let's go down and put it into words here. So if the absolute value of x is greater than k, that's going to be the same as x is greater than k, or x is less than, flip the sign, make negative k. So when you graph, you're going to shade the outsides. And that's just what I showed you guys up above there. So if you have the absolute value of x is less than k, less than is the same as less than positive, greater than negative k. And you guys would shade the middle, but if you have an and inequality, you guys can put it into one inequality. So you could write this as negative k is less than x, which is less than positive k, just like that. this is example number 3 from your guys' notes. I just wanted to do one more with you where the absolute value was not by itself on the left-hand side. You guys can't split the inequality into 2 until this part, the absolute value part, is by itself. So what you need to do is get rid of this minus 5 first and then split it up. So if you have something minus 5, how would you move it to the other side? We would need to add 5. So then you end up with the absolute value by itself on the left-hand side, and 8 plus 5 is 13. But you have to get that absolute value part by itself first. Now, we can go ahead and split it up. So, 3x plus 2 is less than or equal to 13, and 3x plus 2 is greater than or equal to negative. Switch your inequality, switch your sign. And now we can solve for both of these. So, subtract 2, subtract 2. And it looks like we're going to get a fraction, but that's okay. So it looks like for the first one we get x is less than or equal to 11 thirds. Which, if you guys divide that out and actually get the decimal for it, it should be 3.6. So, now we have to solve your second inequality. So you're going to do the same steps, but because you have a negative number, you should get a different solution. So we get 3x is greater than or equal to negative 15. Divide by 3. And get x is greater than or equal to negative 15 divided by 3, which is negative 5. So those would be your two solutions for this inequality.